In this video, we will be solving a question on method of moments. We will be finding the estimate of theta 1 and theta 2 using the method of moments for the given distribution. This is the normal distribution, but here we have the mean as theta 1 and the variance as theta 2. For more on this topic, you need to subscribe to this channel. Solution. If x from the given question follows the mean theta 1 and the variance theta 2. For method of moments, we note that the population mean is equal to the sample mean. The population mean is equal to the sample mean. So when you get the population mean, you equate it with the sample mean to get the solution to the method of moments. But in this case, we have parameters of theta 1 and theta 2, which will look for their estimates. For the first moment, the population mean is equal to the expected value of x, which is the mean, which is theta 1. We can take this as our equation 1. Also, the sample mean is equal to 1 all over n summation of xi, I running from 1 to n, which is our sample mean. We take this as our equation 2. So the next thing to do, we say combine or equate equation 1 and equation 2. So when we combine them, we come over here. When we combine equation 1 and 2 to get the solution for the first moment, we'll get something like our estimate theta 1 will be equal to x bar. So for also for the second moment, for the second moment, we have our population mean to be equal to the expected value of x squared. So we also have our sample mean to be equal to 1 all over n summation of xi raised to the power of 2, I running from 1 to n. So this is our sample mean, while this is our population mean. We can say let this be our equation 3 and this our equation 4. So how do we obtain the expected value of x squared? The next thing to do, we recall that the variance of x is equal to the expected value of x squared minus the expected value of x all squared. So it then means that we make this the subject of formula. So we have the expected value of x squared to be variance of x plus the expected value of x all squared. Of course, if you make this the subject of formula, this will go over to this place to give us variance of x plus the expected value of x all squared. What is our variance? Our variance is given to us here as theta 2. So we put our variance here as theta 2 plus what is our expected value of x? Our expected value of x, which is the mean, is theta 1. So we'll put theta 1 here. Theta 1 all squared, which is equal to the expected value of x squared. It then means that our expected value of x squared is equal to theta 2 plus theta 1 squared. So it means that this is equal to theta 2 plus theta 1 squared. So the next thing to do is to combine equation 3 and equation 4 to get the solution for the moment, the method of moments. So if we combine equation 3 and 4, we say combine or equate equation 3 and 4. If we equate them, we come over to this side to see what it will give us. We come over to this side. Of course, we already have our theta 1 estimate to be x bar because we are asked to estimate theta 1 and theta 2 using method of moments. We have our theta 1 to be this. So we are looking for our theta 2. So if we combine these two, we'll get theta 2 plus theta 1 squared to be equal to 1 all over n summation of xi squared, I running from 1 to n. Of course, to obtain our theta 2, theta 1 can go over to this place to give us theta 2 to be equal to summation of xi squared. As it's coming over to this side, it turns to minus theta 1 squared all over n. It then means that our theta 2 estimate will be equal to the summation of xi minus theta 1 all squared. It can be written as this all over n. So this is the estimate for theta 2. And this is how we can obtain the method of moments for the estimates of theta 1 and theta 2. It's very simple. Once you equate the population mean and the sample mean, you get your solution to the method of moments. For more on this topic, you need to subscribe to this channel.